Hello to Miss Warren's Integrated 3 students. I wanted to take an opportunity to help you guys out a little bit with your inscribed quadrilateral problems. So I believe this is the first one here. You have inscribed angles, but then we have inscribed quadrilaterals. So we're going to talk about the properties within these, okay? Now, to help us out, in the bottom of this YouTube link, and hopefully you're watching this on a computer as opposed to a phone, but a phone I think might work pretty well. I'm going to put this Geogebra Geometry. Now, if you just type in Google Geogebra Geometry like this, you should find it. It's this top one, but I will put a link down below. And this is going to be our tool for exploring this concept, and hopefully the visualization aspect of it will make this make a little more sense, possibly, okay? I am teaching this assuming you know the rules for inscribed angles, which I will be referring to later on, okay? And then, of course, I'm going to need, I guess that's 13T. I'll have to figure that one out here in a second. But we'll go ahead and we'll get started. So on GeoGebra, we're gonna do this. So if you're new to GeoGebra, I'll go very slowly. If you need to pause the video and rewind, of course, take advantage of doing that. Okay. So over here on the side, we have these basic tools, and the first thing that we want to do is we'll even create a situation that looks like this to help us out. Okay. We're going to take this circle with center tool. You're going to click that, and it tells you exactly how to do this here. It says select a center point, then a point on the circle. So we're going to select our center point, then we can drag this and make it whatever we want. I just need a pretty simple circle, so I'm going to click here. Now we have B, okay? The next thing that we're going to have to do is we're going to have to create these segments. So we have the segment tool, and what we're really doing here is we're creating chords. So it's going to look similar to what we have here. Okay. So I'm going to grab the segment tool. I'm going to click B, and then I'm going to drag it over here, just somewhere over here, and that's fine right there. See, and then I'm going to click from C, and I'm going to try to make it look similar to this. It doesn't have to be perfect. Honestly, I could teach this concept without it even looking like this. Okay. But we're going to click this and drag it over here, okay? Next, I'm going to make one more chord, one more segment, and I'm going to go here and then here, okay? And it does look similar to what we have. Now, if you want it to be more closely related, you can, but that's not the point, okay? I would actually be better off just putting it like this and not making it look at all like the same, because I'm trying to teach you guys the concept here, okay? So once you have this constructed, if you need to rewind and see those steps again, go ahead. But if you click this blue arrow, this is the move tool, or you have this move here, you can move any of these pieces. Okay, obviously B is the radius from A to B, so that'll make it bigger or smaller. Here we can move these around, which will help us really understand what the rule is for these inscribed quadrilaterals. So this is a four-sided shape that is inscribed on a circle. Okay. All right, so here we go. The cool thing about GeoGebra is you can really get a good understanding of the rules that are within it, within any of your diagrams, any of your constructions. So over here on the left, we have this More tool. So go ahead and click that. And what you want to find on that side is this measure, okay? And you want to use this angle tool to help you out. So we're going to click the angle tool, and it gives you directions, but I'll also state them. It says select 3 points or 2 lines. We're going to select 3 points because it's usually more accurate to do so, okay? So I'm going to start by clicking D, then C, then B, okay? You can click and repeat this for the next 3 angles as well. So I'm going to go C, B, E, B, E, D, and then E, D, C. All right, so if you click, after you've done your angle measure, if you use the blue arrow here, you can click that and you can move the angles to where they're more, I guess, legible, so you can see them a little bit better. And now you can move this around, and you'll notice this one's not changing, but the others are. These two don't change, but these do. When you move, if the adjacent angles, I'd say, what's the word? I'm drawing a blank on the word. The next angles, the neighboring angles, are going to shift as you move these. And there's a special relationship between these neighboring angles that we want to talk about. Okay, or excuse me, opposite angles specifically. Okay, you'll notice something about these opposite angles. So like when I make, let's make this angle up here, and this is really the whole point of this. It's not that you're going to recreate this situation here. It's so that we can learn this rule about these angles. So look at that. When B is 100 degrees, D is 80. And what happens when I add 94 and 85.9? So 94.1 plus 85.9, it's 180. Okay, so this is the rule that we need, and presumably Miss Warren actually taught this rule to you, but maybe you needed to see it in a more, I would call this a dynamic setting. We're not really interested, and you can keep moving this around. You can keep testing this rule. 116 plus 64, that's 180, right? Opposite angles for these inscribed quadrilaterals are always going to be 180. Okay, so if we make something that looks a little more similar to, I mean, that's kind of close. This is down a little bit. Obviously, the angle measures are different here, but this right here is these angles are always going to be, we call that supplementary. So sort of the rule here, if you want to write this in your notes, so you can write this with me in your notes, just so you have it down. Opposite angles in a inscribed quadrilateral are supplementary. Pretty sure I spelled all that wrong, or right or wrong, I don't know. And I'll even put in parentheses, add to 180, right? That down. Okay, so you wouldn't put that in GeoGebra, you'd put that in your notes. So let's think about this problem here. Let me write on it. It says find the missing angle and arc measurements. Now I'm not really sure about this T here, but we'll see if we can't figure that out together. Again, I haven't really worked this problem before, but right away, actually let me pull up Paint for this. Paint's my go-to now. So right away, I'm going to go ahead and put in the angles that go here. So angle S, we just learned from GeoGebra, we saw the rule, the relationship between them, should add with angle Q up there with 89 to get 180. So this should be 91. 91 right there. So we can add that to our diagram. Next, angle R needs to add with 57 to get 180. So we can just take 180 and subtract 57 if we want. So that's 123. There we go. That's, I think, the main part of this. I know that that's something that she wants here. So 123 should go in there. In S, we should put 91. All right, now we have to find some angle measures, and we're interested in QS. So what's the distance from Q all the way to S? Well, we actually kind of already have the answer for this. We're going all the way here. Sorry, my drawing's kind of bad there. We know that this angle here, 57, is an inscribed angle. So I know that on Delta Math, you have already gotten I think the sections before this were inscribed angles, and the rule is that inscribed angles, this 57 degrees, has to be half of the intercepted arc, QS here. So basically what that means is this arc is double that angle right there. So if I take 57 and I double it, I get 114. And I'm now seeing that that is 137. I don't know why. I thought it said T. I guess because I need to zoom in a little bit more. 137 degrees. I thought it said T for a second, but I think it's just 137 degrees, which is fine. That helps us out quite a bit because the last part here is saying, oh, I also need to write this in. So this is 114 114. All right, PQR. Okay, so we're going all the way. So we're going from PQ. Hold on. QR. There. We need that total distance. Well, we're gonna have to figure out what PQ is, and we're gonna have to figure out what QR is. Well, we have all these other angle measures. We know the total circle has to add to 360, right? So if I do 360 minus 114, which is QS, minus 137, which is PS, I should end up getting what remains. So let's see what that is. 360 take away 114, take away 137. So that should be 109. So we're gonna put that over here. 109. Got it. That is PQ. Now I need QR. So we have to figure out QR here, which we know the whole thing QRS is 114, so it should be 114 take away 41, which is RS, just to get QR. So let's see what that gets us. 73. So we know that this one is 73. So now, a little more addition, we need to do 109 plus 73. That's going to get us our answer here, PQR. 109 plus 73. 182 is what we should get for that one. Okay, so 182. All right, now it's time to check our work. Let's see if this actually works on Delta Math. Pull it up here. All right, so let's see. 123, 91, 140, 182. I really hope I got all this right. I did. Okay. Hopefully that was helpful. No, it's a 12-minute video, a little bit long-winded of an explanation, but hopefully it helps quite a bit. With that information, you should be able to answer the second one here. It's the same concepts happening in here. That should help you with that one, and you should be in good shape now to work all those problems. So, all right, I'll stop the video there.